Okay, using the work we just did in Desmos, what we discovered is that at x equals 0, this value, oh, let me get my pen going. At x equals 0, this value right here, the y value is also equal to the slope of the tangent line, which we know the slope of the tangent line is the derivative. So that tells me that f of 0 is equal to f prime of 0. And I also found out that f of 1 is equal to f prime of 1. So remember, hopefully you're recalling that the derivative is equal to the slope of the tangent line. So this is pretty cool. F of negative 0.5 is equal to f prime of negative 0.5. So they're the same. So what does that mean? It means that the function e to the x and its derivative are the same. This is sometimes called an identity, where you have something and you do something to it and it doesn't change it. So e to the x is the identity when you use a derivative. But don't forget that if you have like e to the 5x, you still have to use the chain rule and do e to the 5x times the derivative of 5x. So let's try a couple of these. What is the derivative of the function r of x equals 17 e to the x? Okay, well actually this one's not so bad because it's 17 times e to the x, so I can just do 17 and then times the derivative of e to the x, which is just e to the x. It's nice. Okay, for number 5, so the same thing for this constant here. A constant, I can just bring it out in front, so I'll basically ignore it, negative 5/3, and then e to the negative x times the derivative of negative x, which would be, so negative 5/3 e to the negative x times negative 1, which I could write as 5/3 e to the negative x. Okay, G. Find the derivative of p of x equals 4e to this big old thing here. So I have e to the something, we're going to call it u, and that's where u equals x cubed minus 12x. So this is a composition of functions. So I'll do, and the number 4 I can basically just ignore. 4 times e to the x cubed minus 12x. So that's because e to the u, when I think of taking the derivative of e to the u, it's just e to the u. Now I need to take the derivative of u, which would be 3x squared minus 12. Pretty cool. All right, number 17. What is the exact equation of the line tangent to the curve, at the point where x equals 1? Okay, so this is a throwback to like the beginning of class, and we're going to need a little bit of space for this. So I need the equation, the exact equation. So this word here means no decimals. So to do this, I need a point on the line. So I'll start by plugging in x equals 1. W of 1 equals 17 times 1 squared e to the first power, or just 17e. So that tells me that the point 1, 17e is on the curve. Then I also need the slope, so w prime is, okay, so this is a product rule, and I can ignore the 17 by just bringing it out in the front. So to do this one, I do the first, which is x squared, times the derivative of the second, derivative of e to the x, just e to the x, then plus the second times the derivative of the first, which is just 2x. Okay, that's the derivative, but I need the slope specifically at 1. So 17, 1 squared, e to the 1, plus e to the 1 times 2 times 1. So 17e plus 2e, which is 19e. This is handy because now I can use my formula, y minus y1, and so I'm using this point here, 17e equals the slope, which I just found to be 19e, and then x minus 1. That's pretty dang cool. Okay, I kind of went through this pretty quickly, so feel free to ask questions on the discussion board.